Hello, everybody, and welcome to episode 133 of I Wish You Were Dead, a podcast about things that used to be alive. My name is Mike, that is Fia, as well as Gavin. And Gavin, have you ever dropped the first line of your notes for a podcast before we even started recording?
I sure have. And you
Every
know
time.
that because it just happened. I spoiled the intro line for the fellow host. But luckily, listeners, you haven't been spoiled. So look
Gavin
forward to that
A+
when we get
intro.
there.
You guys don't understand. Gavin, well done. A+ intro to this episode. It would have been really cool. And then this just, colossal moron drops it before we even start recording. And so we already know what's coming.
Yeah. Okay, you asked me what we were talking about today, and I told you.
Yes, you told me that, 7.5 minutes after you already dropped the intro line. I found out what Fia's dad did for a living. I found out what Fia's dad did for a living in the meantime.
That's true. We'll get there when we get there.
Okay, guys.
But
Fia, don't you dare try and play peacekeeper here. Don't you dare. I'm going to yell at Gavin, and I'm right about this.
Anywho.
Yeah, I was actually mad.
But yeah, so you might have noticed the title of the episode, and actually, listeners, you do know what we're talking about today, because you read the title. But so we're talking about teeth today, not ants, like is what I said previously. We just had some scheduling issues with the guest we were going to have for that episode, so ideally that'll be next episode. If not, I'm not going to spoil what that's going to be, because I might change my mind between now and then. I haven't fully cooked the idea yet, so we'll figure that out.
Cool.
But before we get into the episode, let's do all of our normal intro episode shenanigans. Sophia,
the normal intro stuff. That's a great idea.
Yeah. Let's. You got some housekeeping for us.
Yep. As always, listeners, don't forget to rate the show on whatever platform you listen to us on, and follow us on Twitter, Facebook, and YouTube. Give us feedback about the show and any future topics you would like to hear on the pod. And if you would like to be a guest, which we would really appreciate if you would come be a guest on the show, be sure to fill out the guest form. And all that good stuff can be found in the show notes. And then, as for next episode, Gavin doesn't really know, so...
Yeah. We'll get there when we get there. See you in 2 weeks.
Yeah. So, with that,
I think,
Mike.
Mike. Mike, it's your turn to get yelled at. What do you got?
Okay, all right. Why would I get yelled at? Let's have this conversation. Why would I get yelled at for what I have right now?
Because you forget every time.
Have I ever not had a today in history, though?
No, but you've definitely looked them up while Fia is doing housekeeping. That has absolutely happened before.
Not only has that, that happens regularly. That happens. Yeah. And every single time, I find some good stuff. I'll tell you right now, March 20th in history, a bit of a bummer. There's some... Right. When I say a bit of a bummer, I should say, bit of a letdown, there's a couple things. But, I thought there was, one thing that kind of stood out as an American institution that was founded on March 20th, 1930.
McDonald's?
Colonel Sanders, close actually. Colonel Sanders opens the first KFC restaurant in North Corbin, Kentucky.
Huh.
And I found this out while I was doing my research because I was prepared today, Fenella. Sanders was given the honorary title of Kentucky Colonel by the governor of the time, Ruby LaFoon. The title is honorific and awarded by Kentucky as a state, and it's not a military rank.
Huh.
I would just kind of assume that they made that up.
Me too.
I'm a colonel. But no, apparently it's an actual thing that I assume the governor of Kentucky gives out.
Huh.
Yeah.
That's pretty cool.
Yeah, the more you know.
Yeah, I'll take it.
You know.
Now, follow-up question, both of you guys. How many times have you been to KFC?
Not a lot.
More times than I am proud of.
The answer is once for me, and it was when I had COVID 2 months ago.
Wow.
Let me tell you, the KFC bowl.
It
is so good. It
looks phenomenal.
Especially the day after you've had some beverages.
Yeah, that's true.
Is that a good way to get over it?
it hits home. The mashed potatoes, they just like hug your stomach.
Yeah, I don't know. Whenever I'm in that state of being, it's always pizza for me.
Oh, yeah.
But yeah, see, very rarely we would have KFC growing up. It was usually if we were going out to eat for something like, because you never eat KFC there. You never eat it in the restaurant.
Can say I have not done that.
And so anytime we would go out to eat where we weren't just going to eat it there, we would usually just get like subs or something like that. Or if we were going to take it home, maybe we would get like pizza or something. I
mean, Gavin, you do have a long-running connection with Subway, so I guess that that makes sense.
Yeah,
as a sandwich artist.
For listeners, I worked, I think, 7 summers as a Subway sandwich artist throughout high school and then college. So I know my way around a sub.
I don't know why you had to say it like that.
For legal reasons, it is bread.
What is going on right now? What is happening?
I don't know. There's just all this stuff about like Subway, whether the tuna's real fish or whether the bread is real bread. I've been on the inside. I can confirm it is bread. And it is
on the inside of the bread. Now I have what do you mean you've been on the inside of the bread?
Of the establishment, man.
More questions about the mayo now. Just to bookend our KFC discussion. So where I live in Cicero, there are now 4 chicken restaurants within like a 10th of a mile of each other. You got the KFC, you got the Chick-fil-A, you got the Popeyes, and you got a Dave's Hot Chicken that opened up last week. All like you can see them all. Like I could throw a baseball at all these restaurants if I stood in the middle. Like they're all right there. They're all competing. I'm hoping that we get to see an actual cage match with all 4 of them. But that is
wow.
It's like a wild development in Cicero. And an incredible one too.
Yeah,
that's just kind of like
the chicken wars of Cicero, New York.
I can't wait to cover the chicken wars of Cicero, New York on this podcast after they happen. After there's been some casualties. Like when the next Mike Takes the Wheel episode is going to be wild after that one. But we're not at a Mike Takes the Wheel episode. We're at Swamp Corner. Seagrass Corner.
Yeah.
Yeah. Fia.
And also, just sort of as a little transition, little nugget between the two. Even though Mike just had
the transition.
Mike had an excellent segue. I agree. But not often enough do we actually mention why we do these things at the beginning of the episode.
Big Killer Jones over here.
So we do it today in history because Mike is a high school history teacher. And, he likes to contribute to the podcast. And we like to have him contribute to the podcast. And in a similar vein, I'm in a mood today, guys. It's going to be a very silly episode.
This is going to be an incredible episode. To my one friend that listens to these podcasts, like when you get to this point, just let me know how we're doing. Is this fun for you, or is this like wildly annoying?
Is this content? Is this good content?
It's definitely content. Your second question was a better one.
And then we also do Seagrass Corner with Fia because Fia is working on her PhD in marine ecology. So having some everybody contribute something to the podcast. But anyway, yeah.
Right.
I need to find a better way to do that before we get into the topics.
I was going to say, you took an extra 2 minutes here to just be like, all right, so it's Fia's turn to talk.
Yeah, it sure is. Go ahead, Fia.
Okay, guys, it's Seagrass Corner. Welcome to my Seagrass Corner. We're going to talk about the southern stingray today, which is Hepanus americanus. This is a stingray that I saw yesterday when I was out doing my field work. And yeah, they're tropical. They live in tropical and subtropical waters along the Atlantic Ocean from New Jersey to southern Brazil. They're more of a diamond shape rather than the circular dinner plate form you would imagine other stingrays.
Okay.
And these guys are usually brown, olive, or gray. Mike, why are you raising your hand?
We do this on Zoom, by the way. So Mike raised his hand with an emoji.
I did raise my hand. I think, like every other red-blooded American and Australian, when I hear stingray, there's only one thing I think of. So, yes or no, is this the same one? Or the same kind?
Like the Steve Irwin one?
Yes, the Steve Irwin one. I wasn't even going to say his name.
I actually don't know what type of stingray he was stung by, but if it wasn't in America, then I would probably assume no.
Dude, Steve Irwin could have been on Mars. Like, we have no idea what that guy was up to. It was awesome.
Yeah.
Stingray injured. It was
anyways, these guys...
Great Barrier Reef. Oh, you keep talking. I'm going to see if I figure it out then.
It was a short-tailed
it wasn't
stingray.
The same. It wouldn't be the same one because I just said that it's from the Atlantic Ocean.
Gotcha.
From New Jersey to Brazil. So, yeah.
All right. Tell me more about them.
They have a barb covered in venomous mucus. If you get stung, jabbed by these guys, it'll hurt, but you probably won't die unless you get hit in a very sensitive area.
That Mike is looking at us weird. That's what happened to Steve Irwin. I don't think that kind is like crazy venomous either, but he got stabbed through the heart or something.
Yeah.
Oh yeah, stabbed through the heart I get, but when you say get stabbed in a very sensitive area, I'm not thinking of the heart.
I think that's what she was alluding to. Was getting Steve Irwin.
Right. I just wasn't really trying to explain it. Anyway, let's forget that. Forget that. So these guys, they are nocturnal predators. They like to eat in the dark. They will spray water from their mouths, or they'll flap their fins really vigorously to disturb whatever is going on the bottom, and then they'll eat them. And that's usually consists of small fishes, worms, crustaceans, and bivalves. They kind of just go with the flow. They're opportunistic, so they'll eat when they can, and then they eat very frequently. So they're not, they're pretty much constantly always foraging.
What do they eat?
Oh, buddy.
Fish, worms, crustacean, and bivalves.
Thank you.
And so... one fun observation I found, and also a scientific paper. There's only one that I could find, so I don't know how. Take this with a grain of salt. In shallow waters, they found a commensal foraging relationship between southern stingrays and double-crested cormorants. So basically, they saw that there was a relationship where these cormorant birds were flying over stingrays that they could see through the water, and then whenever the stingrays would dig up the substrate, they would kind of dive down and kind of use their efforts to catch fish and basically mooch off of their work. This was I could only find one paper that this happened, and it was a sample size of 3, so 3 stingray followed by 3 birds. And only in the Florida Keys. So, not sure how legit this is in terms of all southern stingrays. It might just be kind of a Florida Keys thing. It might just be needing more research. Who knows? But that's the stingrays. If you want to learn more about stingrays, I think we do an episode in 84, 85. I can't remember.
Yeah, somewhere around there.
Talk about stingrays.
About sharks, raisins, skates. I think we had one just about sharks.
No, we have a stingray episode.
So we did a sharks one for Shark Week, and then the next year for Shark Week we did raisin skates. Good job, Fia.
Thanks. What are we talking about, Gavin?
Yeah, we're talking about teeth. And why might that be? Well, as I was thinking to myself, after, some of the scheduling things came up with the guests we were going to have for this episode, I was like, what do I want to talk about today? And then I remembered, hey, I have a dentist appointment scheduled for the day we're recording this. So yes, I went to the dentist today. So we're going to talk about some teeth.
What an incredible story. What that's a really good connection to make. I'm really glad that was, and we've got a nice little intro now, everything. We have an explanation. I love that. Well done, Gavin.
Thank you, Mike. I appreciate your positive feedback. You're such a friend that I cherish. Anywho, we have talked about teeth a whole awful lot on this channel. on this show from an episode about herbivory, all about eating plants, episode 127. Episodes chronicling the evolutionary journey of mammals, episodes 35 and 53. To basically every episode we've done about like a particular group of animals. So it'd be cats, whales, dogs, cows, camels, horses, you name it. We've talked about teeth in all of them. But we've never actually talked about teeth themselves. So let's talk about them, talk about what they are, where they came from, and why they're so stinking weird and also so incredibly important to paleontology. So I'll ask Mike first. Fia might know more about this because, as we learned before we started recording, Fia's dad's a dentist.
And I clarified. Apparently, he's a good dentist.
A good dentist, yes.
Yes, he is a good dentist.
Yeah. So I'll ask Mike first. Mike, what are teeth?
So you always hear about how teeth are bones, and I feel like that's not actually true. But I don't have much else to go on. Teeth are bones. I believe they're actually like made of a substance called dentin and enamel.
And so far.
Their two main purposes are both food related, to be able to bite into food, to cut it into like a mouth sized piece, and then to mash that food to get it down, to get to properly eat it. And I guess the third one for some species is like as a means of attack, to either bite, or if it's a snake, to inject venom. So I'm going to go with bone or bone-like structure. Made of dentin and enamel, used for eating and self-defense purposes. Do I want to say they come in early childhood, or is that just a human thing? I'm going to leave that part out. I'm going to assume that there are some animals born with teeth.
Okay, cool.
Fia?
Go ahead, Fia. What do you got for what are teeth?
I swear to God, she's going to shut me up right now.
No, I actually was going to say that Mike did a really good job, and I think that I just concur.
Cool. No, I mean Mike hit pretty much all the major points.
It feels so good when I can contribute to the podcast.
Yeah.
Yeah.
But yes, because I'm not really going to talk about anywhere else here. But yes, the majority of animals are born with teeth. That's kind of just a mammal thing, where some mammals aren't, some are, but most are not.
Is there a particular evolutionary reason why humans are not born with teeth and other mammals are not born with teeth, or is that just kind of the luck of the draw?
Well, human babies are born pretty half-baked compared to a lot of other, even mammals. In order, our pelvises sort of had to shift a weird way when we started standing upright, which means that we had to start giving birth to less developed fetuses. So humans are just a little undercooked when we're born to begin with.
Understood.
But it also,
I don't know how I feel about that.
If you guys could see what Fia's face was doing just then.
That analogy just seems a bit off.
Well, I mean, they're called buns in the oven. I feel like underbaked.
All right, okay. That's fair. That's fair.
But yeah, also another reason for mammals in general, having fewer teeth at birth than like reptiles, for example, is our parents take care of us and we drink their milk. You don't really need teeth to drink milk.
That's what I was thinking.
In fact, I can imagine it being a detriment to... Yeah, okay.
Whereas something like a lizard, most lizards don't take care of their young. So fresh out the egg, the lizard has, their yolk sac, they're still absorbing that for maybe a couple days. Depending on the species, I'm sure it varies a lot. But they need to start hunting and eating food basically immediately, so they need teeth. And that's, broadly the case with fish and other reptiles besides lizards too. But yeah, so as Mike sort of alluded to, they are not bones, but they are quite similar. Enamel and partially dentin, but mostly enamel, is made up of calcium phosphate. But yeah, so teeth are mineralized structures in the mouth that help break down food through mastication, which is the fancy word for chewing. Although, as we'll talk about toward the end, it's pretty much just mammals that chew stuff. For example, like birds don't have teeth; they can't chew stuff. Most like snakes swallow stuff whole. Most fish swallow stuff whole.
Is the
a lot of lizards? Yeah.
Is the work that would normally be done by chewing just done by digestion at that point?
Yeah.
Okay.
Well, it depends. In some, like I know some crocodilians, I know birds for sure do. Probably some lizards swallow stones, and they have like a special organ in their throat that like holds the stones, and the stones like grind together, and that manually will chew up the food for them.
That is wild.
Yep.
Especially like the crocodiles have some teeth, like they could do that themselves.
Yeah, but they're not. As we'll talk about,
they're not like the flat ones,
right?
Oh, okay.
Yeah, we'll get into that. And so teeth are most often attached to 3 bones in the face region. I was going to say skull, but your jaw is technically not your skull. But yeah, so they are attached to the lower jaw on the dentary. So that's in mammals, that's the only bone in the jaw. It's just a single bone, one part on each side. In reptiles, there's lots of other bones in the jaw, but teeth are only on the dentary in the lower jaw. Mm-hmm. And then teeth are primarily on the premaxilla and maxilla in the upper jaw. But in some groups, mostly reptiles, they can also be found on the pterygoid, the vomer, the palatine, and also gill arches in fish. So once you get up onto land, things simplify a little bit, as is usually the case. But yeah, teeth are generally in the mouth. Not always, as we'll talk about. There are 2, they're mainly made up of 2 types of material, sometimes with a third thrown in there. So on the outside, the part that you see and the part that you brush, ideally twice a day, is enamel. That is one of the hardest biologically produced substances in the world. For sure, the hardest part of a human body, at least. Underneath that enamel, so it sort of makes like a little shell around the top part of the tooth. Underneath that is dentin, which is softer and still partially mineralized, and runs throughout most of the tooth. So that's sort of the cap of enamel. Underneath it is dentin, still pretty hard, but not, as hard as the enamel. And then sort of as a coating just around the roots, as a really thin coating, there's a material called cementum, and that is very, very chemically similar to dentin. It just has a little more biological stuff going on that helps it grow and stay healthy.
Cementum?
Yep.
Like, is it the name any relation to cement, or is that like, am I way off base here?
So that is how your teeth connect to your jaw bone.
Okay.
So there are ligaments that connect the cementum to your actual jaw.
Mm-hmm.
And then also in some other groups of animals, like I know horses like use cementum all over the tooth instead of just in the roots. And in that case, it does sort of help stick them to each other a little bit loosely. Other than that, why it's called cementum, I don't really know.
Okay.
But yeah, so unless something's going quite wrong with your teeth, you will never see your cementum. That would be real bad. And then there's this area sort of at the center called the pulp. That is where the nerves and the blood vessels and stuff that are in your teeth that help keep your teeth alive and healthy.
There's a part of my teeth called the pulp?
Yep.
That's yucky.
I didn't have to know that, man.
You sure did. Okay, so that was a brief run through of each of these parts. So let's talk about each of them in a little bit more detail. So first, enamel. Enamel is very, very hard. How hard? Well, it is a 5 on the Mohs hardness scale. That's what we use for minerals. If you've ever scratched a rock or a mineral with something like a nail or a penny, you're testing its hardness. If you did that in if you go to high school in New York, you've probably done this because New York requires earth science.
What is a diamond?
Diamond's 10.
Okay, that's what I thought.
Yeah, and it's not logarithmic like some other things in geology. I don't remember the exact term, but it's instead of 2 being 10 times as hard as a 1, it's twice. So a 2 is twice as hard as a 1, a 3 is twice as hard as a 2, so on.
Is that exponential?
No. Again, I did look at I did see the term somewhere, but I forgot to write it down.
Okay. Okay.
If you go to the Wikipedia page for Mohs hardness scale, it'll be there. So yeah, that's how we measure hardness in minerals. And a 5 on the scale means that it's harder than all of these things: bronze, platinum, iron, nickel, and ordinary non-hardened steel. So your teeth are harder than just regular steel. It's pretty cool.
I'm into it.
Weird question.
Yeah.
Is it harder than gold?
Yes, gold's quite soft.
That's what I thought.
Okay, yeah. Because, like, people, like, tell if it's, like, real gold by, like, biting it. Yep. And then, like, if it bends, then it's, like, real gold.
Yep.
Cool.
All right. Okay.
I mean, like, this is just, like, a memory I have.
No. I'm not. I was, like, I'm not sure exactly what I think of. It wasn't that, because I think we've all seen that. That was my understanding, was that it was a real thing.
Yeah, totally. So, enamel's primarily made out of a mineral called hydroxyapatite. That is that, calcium phosphate that I was talking about earlier. So, the hydroxy part of it sort of refers to a hydrogen atom in its chemical formula, and that hydrogen can be swapped out for a chlorine or fluorine atom to become more acid resistant, and that's why we use fluoride and chloride in things like toothpaste, mouthwash, and public drinking water. So it's actually messing with the chemical formula of the mineral in your teeth. That's what it does. And it took us a long time to learn that. And since we've started putting fluoride in the water, dental health has gotten exponentially better. So don't listen to things online about fluoride in the water. It's fine.
I mean, not only is it fine, like, it's a good, like, it is an active good. Like,
yes,
it's like,
absolutely.
Right, not only is it like, they're putting the fluoride in the water for no reason, and like, it's weird they're doing it. Like, no, like, there's a very good reason. It's very well documented why there's fluoride in the water.
Yes, absolutely.
Enamel is... frogs.
Yes. Alex. So enamel is kind of unique in the body in that it is one of the few materials made by the body that is not actively maintained by the body. At least in humans. There are some, like, rodents and stuff to it, but we'll talk about them in a bit. But enamel is not maintained by any cells, and it never gets repaired. That's why dentists, no offense to your dad, Fia, are so uptight about you taking care of your teeth. Because your teeth cannot heal themselves like other parts of your body can.
Yeah.
And so enamel, like I said, makes up just the outside of the crown of the tooth. That's just the top part above the gums that you can see. And because enamel is fully mineralized already, that leads to it becoming excellent fossils because the work is already done. And also, it helps that you have multiple teeth, especially in things like a lot of reptiles, many, many teeth throughout your life. So just statistically, teeth are much more likely to get fossilized to begin with. So that's reason number one why they're so important to paleontology. We just get loads of them. The next part, dentin. It is still partially hydroxyapatite, but instead of hydroxyapatite making up 96% of it, like it does in enamel, it's only around half of, like, the mass of dentin. The rest is organic material, things like collagen, different proteins and stuff like that, and then also water. Those water and the organic stuff make up about the other half of dentin. It's still relatively hard for a living tissue. So dentin is a 3 on the Mohs scale. It's about as hard as brass or bronze. But unlike enamel, like I mentioned, dentin is a living tissue that can heal itself. However, because it's so much softer than enamel, about 4 times softer, that makes it much less resistant to wear from eating or just talking and doing stuff with your teeth. It's also quite sensitive, so using it to chew on would probably be really uncomfortable. Lastly, the cementum, not a ton to say about this. It is chemically basically the same as dentin. It's just sort of structured, crystallized a little differently. And so this layer is what actually attaches the tooth to your jaw via a ligament. So just a little, really thin shell around the dentin on the roots. And then the pulp. So this is at the center of the tooth. It runs up through the roots as well, and then forms a little pulp cavity in the crown. And again, blood vessels, nerves, whenever your teeth hurt from eating something cold, this is what sends, these are the nerves that sense that. Cool. So that's the different parts of a tooth. Let's get into some terminology here. Unlike, every part of science has way too many terms and acronyms and things like that honestly make science really inaccessible. There are certain Wikipedia pages that you go to that are just completely unintelligible by a layperson or even somebody who's like vaguely familiar. I've been to some like deep chemistry pages on Wikipedia, and I can't tell what's happening at all. So if you go to look at anything, dental or about teeth in the rest of the animal kingdom, here's some of the terms you'll probably hear. So we often talk about teeth in quadrants. Top left, top right, lower left, lower right. Especially in paleontology, because a lot of times we'll only get one quadrant. So it helps to know the differences between the quadrants, if there are any. I actually was talking with my hygienist today when I was at the dentist, because how dentists number teeth, they start at 1 at like, I don't remember what part it is, but then they just go up to the max number of teeth in your mouth. Whereas in, the rest of animals, we just start at the front on one quadrant and then work toward the back of that same quadrant. And so 1 doesn't mean anything necessarily, but to a dentist, 1 means a particular tooth. To a paleontologist, 1 means nothing because it doesn't tell us what quadrant we're in. Your teeth can come in also different shapes across your mouth. These are called heterodont or homodont. Heterodont means teeth in different parts of your mouth look different. This is what you have. If you feel your tongue across your teeth, your incisors are flat and chisel-y at the front. Then you have your canine that's kind of sharp. You have your premolars that are sharp but kind of flat, and then your molars in the back that are flat for grinding and stuff. That is heterodont. You have different teeth. That is almost exclusively a mammal thing. There are some reptiles and some fish that do it, but all of them, for the most part, are homodont. If you take a tooth from the front of the mouth and a tooth from the back of the mouth, they more or less look the same. Again, talking about the type of tooth, pretty much exclusively a mammal thing. These are your incisors, your canines, molars, premolars. Your teeth can be different heights, relative. The crown can be really tall compared to the roots, or the root can be really long compared to the crown. You can have brachydont teeth. This is what you have. Your teeth are really short, and your roots are really long. Mesodont, they're about the same. Then hypsodont, the crown is super long, and the roots are relatively short. This is like horses and cows and stuff that eat a lot of grass. Your teeth can be kind of blunt. Bunodont, like your teeth, good for grinding and mashing and stuff, or they can be cecodont, which are like a cat teeth that are really good for slicing through meat and stuff like that. Mammals, and we'll talk much more about this at the end, have cusps on their teeth. Most others don't. If you feel your canine tooth, it is just kind of like a single spike. That is like a single cusp. And then as you move toward the back of your mouth, you have more cusps on your teeth. That is, again, almost exclusively a mammal thing. But each of those cusps has names. I had to learn all of them in very high detail in grad school. But I will not bore you with all the different names and terminology for like the sub-terminology of teeth. We're already going pretty hard in the paint here. Yeah.
Sorry, random thought. Would you consider yourself a paleontology dentist?
No, because I think of dentist as like healthcare.
Okay. Would you consider yourself like paleontology tooth guy?
Yeah, I would. That was the vast majority of the fossils I worked with for my master's were teeth. Like, I would say easily less than a quarter if you just look at raw, number of specimens. easily less than a quarter. I'd say like less than 10% were non-teeth. So yeah, studying teeth is the main reason. If you go into mammalian paleontology, you will spend almost all of your time looking at teeth.
Shout out to teeth.
Yeah. Your teeth can kind of come in also different like styles for how it sits in the jaw. So your teeth, if you think of like your jaw, how it has like little pockets in the jaw that the tooth sits in, that is called thecodont. That is pretty much just a mammal thing, as well as archosaurs, so dinosaurs and crocodilians too. Most reptiles are called pleurodont, and they're kind of like half-socketed. They sort of sit on like a little shelf on the inside part of the jaw, and so they are attached in like that half socket to the jaw, and then the other half is just kind of open. Amphibians do this super weird thing. They have what are called pedicellate teeth. The tooth, crown, and root are separated by a pedicel made out of dentin. So they have the root at the bottom, then like a little joint, then the pedicel, then another little joint, and then the crown. And this makes their teeth kind of flexible. They can their teeth can wiggle, and I don't like it.
That seems like a poor design.
Yeah.
Does it work well?
Apparently.
Okay.
But, so could you give me an example of what kind of amphibian has teeth?
Most of them.
Really?
Yeah.
Like frogs?
Mm-hmm.
I guess I just never really looked in the mouth of a frog before.
I mean, they don't use them for a lot because they, especially frogs, just use their tongue a lot of the time.
Right.
Right. Salamanders do have a very mobile tongue like that. Not quite as much as a lot of frogs. But if you think of like a salamander going to eat like an earthworm or something, they all of them have like pretty teeny tiny teeth. So that's probably why they can kind of get away with this.
Yeah.
They're also not eating particularly large prey. There are some frogs that do. Like, there are some frogs that eat, like, mice and rats and stuff, just because they're gigantic frogs. But, yeah, those are the only ones that I think, like, really give their teeth too much of a workout.
Okay.
Yeah. No, that was a good question, though. And then the last way that teeth sort of sit in the jaw are called acrodont teeth. These sort of sit, there's like a little groove on the top of the jaw that the teeth like kind of sit on. Not like a socket, because there's not like individual little holes. It's just like a single groove that the teeth just kind of sit in. This is how most bony fish do it, as well as a handful of species of frogs, and then a couple lizards like chameleons also do this. But it's mostly a fish thing. Some more terminology. The number of teeth you have in each individual, like, slot. So, Mike, you were sort of talking about this, about, like, baby teeth and adult teeth. That is called diphyodont. You only have 2 teeth in each slot ever. That is most mammals, and that is exclusively a mammal thing. You have your baby teeth, and then your adult teeth. I don't really know why. At some point, there must have been some kind of bottleneck in the mammalian gene pool where it's like all the mammals that were left were like this. I tried to find it. There was never a great reason given that I could find anyway. I'm sure that there are hypotheses, but there doesn't seem to be like a dominant hypothesis at the moment. Just spitballing here. As we'll talk about, mammals invest a lot in each individual tooth. And if you're constantly replacing them, that's a lot of investment to then just throw away.
Okay.
If that makes sense. That's a little bit of a chicken or the egg thing. Whether it's like, do we have fewer teeth because we invest so much in them, or do we invest so much in them because we only have 2? Yeah. So that is diphyodont. Di meaning 2. Apparently, there is monophyodont, which is there's a single tooth in each spot in the mouth ever. As far as I know, there are no animals that really have this, but I kept seeing it around. I think I saw somewhere that the only thing that this could conceivably apply to are platypus, where in the eggs, platypus skip the baby teeth, just have adult teeth, and those teeth go away around the time when they leave the nest. So adult platypus are toothless. But technically they do have teeth, and they don't replace them. So they created this term seemingly just for platypus.
Typical.
Yeah. However, I've also seen that this can sort of apply to, like, not like species, but individual teeth. So, for example, in humans, our molars technically are monophyodont because we don't have baby molars. We have baby premolars, but they're not molars. So we only get one set of molars, but two sets of incisors, canines, and premolars. Lastly, there is polyphyodont, which is your teeth are just continuously being cranked out throughout your life. The most obvious example of this is sharks.
Yeah.
Everyone has seen pictures of the inside of a shark's mouth. It's just full of teeth. There's the ones that they're actually using, and then just the rows and rows that they have ready to sort of be pushed up and replace them. And, other examples of this are pretty much anything that's not a mammal. Fish, amphibians, reptiles, but also weirdly includes a handful of mammals. Kangaroos, apparently, do this? Sure. The ones that I knew about before this, though, are manatees and elephants. They are loosely sort of considered polyphyodont because they have one giant tooth in each quadrant at a time, and then the new one sort of pushes the old one out. And they're often called marching molars because there's just like a constant slow stream of teeth being pushed, marching out of the mouth. But I said they're kind of loosely polyphyodont because you can still tell, like, oh, this is a premolar versus a molar. So you can tell roughly how old the elephant was. If it still had premolars, then it wasn't all that old of an elephant. Yeah.
Interesting.
Yeah, and they still go out in the normal order, first premolar, second premolar. On top of that, just like constantly replacing teeth like some reptiles and stuff do, there's also what are called open-rooted or ever-growing teeth that don't fall out and get replaced like sharks or crocodiles and stuff. They just continuously grow. And this is the case mostly with things like tusks, like elephant tusks. That is a single tooth the whole time that just keeps on growing. Also, rodents do this, mostly with their incisors. That's why they're always chewing on stuff. And if you have like a pet rat or something, and you don't give it something to constantly be chewing on, its teeth can grow too much and be really damaging for it.
Really?
Yeah.
Okay.
And I think in some, I think beavers, their molars are also continuously growing. Yeah. It's like Play-Doh teeth. You just constantly pushing them through the mold, and they're just pushing out Play-Doh. But yeah, so those are the main examples of that. I don't think there are really any reptiles that do anything like that. So let's put all of these terms together because they can be, it sounds like a lot of terms, but they can be swapped in and out pretty readily. So any of these can be paired with any of the others. So humans, you're familiar with your own teeth, I hope. Humans are heterodont, meaning we have different teeth across the mouth. Bunodont, we have sort of knobbly teeth, good at crushing stuff up. We're thecodont, so we have teeth that are in sockets in our jaw, and we have diphyodont teeth, so we only have the two. Crocodiles, on the other hand, are mostly homodont, so they're all pretty much cone shaped. The ones at the front are a little sharper than the ones in the back, but they're all the same general shape. They're also bunodont. Their crowns are not very short, or brachydont, so their crowns are not very tall. They're also thecodont. They have socketed teeth too. but they're polyviodont. They grow new teeth constantly. So these can all be swapped in and out and be, mixed and matched with each other. And just because some of these terms might be the same, all of these terms might be the same for two species, that doesn't necessarily mean their teeth all look the same or are adapted for the same things. If we go through most of those categories, humans and cats fit them both the same, or both fit the same for pretty much all the categories. However, you would never confuse a set of cat teeth for a set of human teeth. Number one, cats have far fewer teeth than we do.
Gotta be smaller too, aren't they?
Right, but even like a large cat, like a lion or something.
Oh.
Yeah, they just have far fewer because they don't eat plants almost at all. Yeah, your house cat might chew up your house plants occasionally, but like out in the wild, they don't really eat much plant material at all. So they don't need grindy teeth to chew up plants. They just need stabbing and slicing teeth. That's all they need. So they just got rid of the ones that don't do that. But all across that suite of stuff, they're all brachydont, thecodont, diphyodont, heterodont. Almost all of it's the same, but they look totally different. And so far, you might have noticed that I've only given examples of any of these things and used terms that would only apply to vertebrates, things with bones. Sorry, Fia. That's because true teeth can only exist within vertebrates, specifically gnathostomes. So that is your jawed vertebrates, fish, and everything else. Amphibians, reptiles, mammals, and such. Some other animals might have hard structures near the mouth that do similar purposes, but they're not teeth. Like I know lampreys and hagfish are vertebrates, but they don't have jaws. And they have these like keratin, almost like horns, that they functionally use as teeth to like latch on to whatever they're trying to eat. Or I know leeches have something kind of similar too. But they are not teeth. And so that is broadly modern day teeth. That is how we talk about them, all the different terms that we use to describe teeth. If you were to pick up, a relatively intact tooth, you would have all of these words to describe it. And it almost kind of works like a flow chart, where that can narrow down pretty well what kind of animal this tooth came from, just by going through each of those pieces of terminology that we used before. So let's talk about teeth evolution, because it's an interesting story. But we're going to talk about it first, not about its evolutionary history, but about why teeth are so funky and weird. And I think the biggest reason is that teeth are arguably under the most selection pressure of kind of any part of the body. And the main reason is if you starve to death because you can't catch and process food, you can't mate and have babies. And that ultimately is the end goal of evolution, is to mate and have babies. And so if your teeth don't work, you can't do that. And that is like step one to existing, is being able to eat. So if you can't catch your food and you can't process it well, then you just starve. And so because of this, teeth are at the beginning of that process. And teeth, especially in mammals, are some of the most customizable parts of the body. Firstly, you have lots of them. If you think of, the only bones that I can think of where you have, again, teeth aren't bones, but you know what I mean. The only bones that you have more of are your fingers, your finger bones. That's pretty much it. And your vertebrae. But because you have lots of them, they can be diversified to do lots of different jobs. And just think about when you're eating something, think about what you use your different teeth for. You use your molars for crunching on hard stuff. You use your front teeth for like scraping stuff. Use your premolars kind of for cutting, and if you chew like a nice piece of like steak or something, you're mostly using your premolars for that. And because your teeth are sort of compartmentalized like that, you can evolutionarily afford to experiment with a few teeth at a time without losing the function of your teeth as a whole, which is really important. That's a big question that's often asked with big evolutionary transitions, is like, well, how did it do this without losing the functionality of the thing at all? That's a big conversation with like mammals, how we got all these different inner ear bones. We have 3 of them that came from different parts of the jaw bones. But it's like, how did your hearing work in that middle stage? How did your jaw work in the middle stage? You kind of need both of those things to work if you're going to live. But with teeth, you don't have that question because you have other teeth that can still do the job. And as an example, right. This is most likely what happened with venomous snakes, especially the ones that have like the big fangs, because most snakes are technically a little bit venomous, even if they can't if they bite you, you're not going to go to the hospital, but you might get like a little rash or something around the bite. But the few groups that have like dedicated fangs could evolve their fangs to be fangs because the rest of their teeth still work just fine for catching their food. And then, compare that to doing something super radical with your limbs. You really can't still use them for their old purpose if you change them too much. Birds can't walk around on their wings anymore. So, but because we have that backup of the rest of the teeth, that's not really a problem. So they're under a lot of pressure, but they're also super adaptable. That's sort of the point we're getting across there. So where did teeth come from in the first place? And this was a question for a long time because teeth are very weird. There's a lot of genetic studies looking into teeth because at first people were like, oh, there's bones. They come from the same genetics as bones. But then we kind of realized, no, they're not. They're not bones. They're different. And so we looked into the genetics, and the answer will surprise you. So in the earliest jawed fish, so long time ago, there were fish that had mouths. They just didn't have full jaws that had bone in them. But the first group of fish that did have these full boned jaws are called placoderms. They're these, very large, diverse group of armored fish. The front half of their body was covered in these like armored plates. That's usually all the fossils we have of them is this armor. And so they didn't have teeth. They just used a sharp-edged bone in their jaw to just cut their food in half. So they were just chomping directly. They used their top jaw and their bottom jaw like a pair of scissors. So they didn't meet each other. They like slid past each other.
That's kind of cool, actually.
Yeah, super cool. However, on the rest of their bodies, they had scales very much like modern sharks have. Which, in sharks, we call them dermal denticles, which means skin teeth.
That's cute.
Yeah. And these scales are not like the scales of bony fish, like bass or tuna or something like that. Those on the bass and the tuna are made up out of a combination of bone and keratin. In sharks, their scales are made up of, stop me if you've heard this, a pulp cavity of blood vessels and nerves, which is surrounded by dentin, which is surrounded by a hard inorganic substance similar to enamel, a little bit different, but functionally the same. So that is exactly the same structure as teeth.
Right.
And they're so similar that it's basically taken as fact that they are homologous structures to teeth. Basically like your arm and a bird's wing. They look kind of different, but they came from the same evolutionary origin point. Mm-hmm. And again, lots of evolutionary genetics studies going on here. That the genetics, if you sort of mess with the teeth, the genetics of an embryo, if you do it right, it can mess with their skin too, and make teeth grow in weird places on the skin. So we know for sure that the teeth and the skin are related. Unlike the genetically, unlike the jaws in the teeth, which is very counterintuitive. So then the question sort of becomes, well, which came first? The teeth or the scales? Did they evolve teeth first that then spread out of their mouth and across the body? Or did the scales work their way from the skin into the mouth? And
well,
based on all the evidence I've seen, like, there's definitely still a bit of, work being done around this. But for the most part, it seems like the evidence is pretty heavily pointing toward them having scales that then grew on the jaws, that they used as sort of...
That seems...
Yeah.
Yeah, like most intuitive.
Yeah, and I'm sure, like, genetically... It is probably some kind of a beta column A, beta column B. It usually is in complex things like this, but
yeah.
But yeah, it seems like they had these scales that they then sort of, since they had jaws now, it sure would suck if your jaws broke, or even just like the spiky parts of your jaws chipped because you bit something that was a little too hard. And that kind of makes sense. They're a regrowable resource, whether or not, the enamel isn't, but you can just grow new scales to begin with. Most fish can do that. And the scales are harder than bone. Enamel is harder than bone. And so if your mouth scales get damaged, you can just grow new ones. Unlike if your jawbone gets damaged, that is a lot harder to repair. And also much worse for you when it does get damaged.
Mm-hmm.
Yeah, so there's an obvious benefit for putting the scales on the jaws. So now we have teeth-like things in the jaws. And it's likely it sort of worked as sort of like a chainmail or something on your teeth. But it was just sort of like a coating. Not necessarily organized in like the nice, neat rows that we have teeth in, that we see in animals today. And so the fossil record of this change from just like this covering of like skin over your jaws to like a dedicated row that is part of the jaw, we don't really see that very well in the fossil record, unfortunately. We do have some bits here and there, but for the most part, we're still working on this pretty hard. There was some research from late 2022, so pretty recent, that found the earliest tooth whorls from the Silurian period, so about 440 million years ago. And so these whorls are basically a sort of bone that holds the teeth. That's not quite accurate, but it's accurate enough for us at the time, at this moment. So the whorls basically just show that the teeth were organized to some degree. And that they were more like shark teeth than anything else we have today, where they're sort of organized in sort of a vertical replacement row where the whorl sort of rotates and new teeth pop up. So this is just the first evidence of like an organized tooth pattern way back 440 million years ago. Then after that, for most of the time the vertebrates have had teeth, they were just kind of conical spikes, like you see in things like crocodiles or a lot of fish. Some were modified to be a little bit rounder, better at crushing instead of just grabbing. Like I know stingrays have teeth that look like pebbles, basically. And they're organized into like plates to just sort of crush down on those hard bivalves and things that they eat. Things were doing that at this time too. But even still, all the pebbles more or less look the same. So there was no teeth differentiation going on. There was no tooth sockets, really. Just mostly those spikes, which if you're in the water, that kind of makes sense. Because in the water, teeth are for sure helpful when you're in the water. But if you're eating other things that are swimming around, you don't necessarily need them. Most fish use vacuum feeding. And that's just where they open their mouth real fast. A bunch of water rushes in their mouth, and often directly into the stomach. Ideally, with whatever fish you were trying to eat. And so, the teeth basically, if it doesn't make it all the way into the stomach, they stop it from going back out. That's one of the main uses of fish teeth, besides things like sharks that are attacking like prey, relatively large compared to themselves. If you're thinking of like a grouper or like a large fish, most of what they eat are much smaller fish.
Mm-hmm.
And that method cannot work on land because air is just not dense enough to be able to suck something in like that. So once fish started to come up onto land, they had to figure out new ways to catch their food. And conveniently, your teeth are already right where your food goes.
Just repurpose there for them.
Yeah.
Okay.
And so, not so conveniently, fish teeth are very bad, generally, at withstanding much force without breaking or just getting pulled out. And while a lot of things can grow new teeth, they'd prefer not to, because then that's just more resources they have to spend on replacing teeth.
Yeah.
So this is when we start to see the different ways that the teeth attach to the jaw. So this is when we start to see the pleurodont, which is like the half socket, where they sort of sit on the little shelf. That just provides some extra support for the teeth. And, just a little more, more ability to withstand the forces of biting on things directly.
Mm-hmm.
And so this was kind of the case from the late Devonian period through the Permian. So this is ballpark 370 to about 275 million years. So for 100 million years, pretty much everything had teeth that were sitting on their little shelves and still mostly just relatively simple cones. And this kind of makes sense, since at this time vertebrates were still mostly eating invertebrates like insects and each other. No vertebrates were really eating plants at this point, so they had no need to change up their teeth. They just needed stabbing and grabbing teeth.
Stabbing and grabbing teeth.
That was just off the dome. You like that?
Well done.
Yeah, I did like that.
So the Permian period, though, this is, as per usual, the Permian period is a very well known as like a time of change in a lot of different groups of animals. So this is when we start to see herbivory become much more widespread with invertebrates. And so, more complex teeth were needed to be able to process plants more thoroughly. We had a whole episode about this, about herbivory, because eating plants is really, really hard. And so that all starts with teeth. Being able to process the plants more thoroughly before you swallow it. This is also when we see thecodont teeth. So this is, the teeth in sockets like you have. This is when those first show up in archosaurs. This would be the ancestors of crocodilians and dinosaurs. And then on the mammal lineage side of things started to change a little bit in a different way. So some groups, like the one including Dimetrodon, started to differentiate their teeth just a bit. Dimetrodon, very famous. People often think it's a dinosaur. It looks very much like a reptile, but it's not. It's the one that sort of looks vaguely Komodo dragon-like in a body, but has the big sail on its back. But so Dimetrodon means two tooth shapes, referring to the sharper teeth at the front of the mouth and the much blunter teeth at the back of the mouth, because they were starting to make some of their teeth different from each other, like we see in mammals today.
Okay, yeah.
And this is simplifying things quite a bit. Honestly, this is where things kind of get static a little bit for reptiles. Most lizards today still have those pleurodont teeth, the ones that sit on the little shelves, that look very much like they did at this time in the Permian period. Crocodilians have very similar teeth to their Permian ancestors, just sitting in the sockets, just like cones in a socket. And, certain dinosaurs had some honestly really crazy, amazing teeth that I'm sure we will talk about some other time in episodes about those specific groups of dinosaurs. But I study mammals, so we're going to talk about mammals.
Yep.
And mammals, for sure, are the most intense about their teeth. Somewhere down the line, like I mentioned earlier, mammals got stuck with only having the two sets. And so we had to really make the limited number we have super useful and last for a really long time. And so throughout the middle of the Mesozoic era, this is the early Jurassic and through the early Cretaceous periods, mammals developed what is called the tribosphenic molar. Basically, molars with 3 cusps instead of just 1. Also, later on, many groups of mammals added a 4th, but that came later. So if you think of your canine tooth as a single cusp, just the single point, our teeth went from that to your flatter, bumpier molars that you have at the back of your mouth. These cusps are what allow mammalian teeth to be so much more varied, because you just have many more pieces to change and to work with. And because of this versatility and adaptability, that is what really allowed mammals to be good at multiple types of chewing at the same time. And to be able to chew really to begin with. So if you think about, if you have ever seen a picture of like a crocodilian mouth, like a crocodile or an alligator, their teeth don't meet each other. They don't touch like point to point. So that is uniquely a mammal thing, where your teeth meet each other head on. And this is because of all of those cusps. So the cusps on your upper teeth fit in between the cusps on your lower teeth. And that's what allows us to sort of squish and crunch and slice and do all the things that we do with our teeth. And this is what, like I said, you want to clip stuff, you want to like cut like or snap like a celery stick in half, your incisors got you covered. You want to cut up some meat, your premolars are nice and sharp and ready to do that for you. You want to crush up some peanuts or something, your molars got you covered there too. And so all of these cusps are what allow us to do that. Like I said, the cusps sort of interlock with each other and are sort of conformed to each other, the top versus the bottom. And that gives us the nice chomping that we're able to do. And there's so many benefits to this. Chewing your food allows for better food absorption in the gut because you're already manually breaking the food down into smaller pieces. Like we mentioned, a lot of reptiles have to literally eat rocks in order to do that. That saves us a whole organ that we don't have to have. And lots of rocks that we don't have to deal with carrying around all the time. This is, all in all, this is really what allowed mammals to become as successful and diverse as we are today. You can do everything from rounding off those cuts to make good grinding surfaces like you have in your molars. You can put ridges from one cusp to the next to reinforce the tooth, sort of like horses do, or to make a sharp cutting surface like cats do. It makes your teeth very modular and very adaptable. And, lizards and reptiles and stuff are also very varied. But in terms of where they can live and the stuff they can eat, a lot of them are a lot more restricted than mammals are. And that's all thanks to our teeth. So the possibilities with mammalian teeth are kind of endless. And that's where I'm ending off the episode, is talking about the endless possibilities of your teeth.
Would there ever be any hope? This is a wild question. Like people that are doing like biohacking and trying to do like weird stuff with the human body. Is there ever any hope for like creating naturally occurring like third and fourth sense of human teeth?
I don't know. I've never heard of that. I would think.
Neither have I. Like it's just something I'm like. It seems like it'd be if somebody could pull it off, it would be a good idea. At least it seems like it would be. But
I think we'd have to really play around with it a lot, and I don't know how ethical that is. Right. Because I'm sure they'd screw it up a lot before they got it right.
I imagine there might be some places teeth growing that they're not supposed to grow.
Yeah, but I don't know. That's a good question. That's definitely something that I might look up, while I'm laying in bed after we get done here.
Yeah. It's gonna be in my head for like an hour at least now.
But yeah, so this is your mission should you choose to accept it after listening to this podcast, go argue with your dentist.
Go argue with
calling dad.
Yeah, I was gonna say go argue with Fia's dad specifically.
Yes, because so the one thing that I will tell you to mention to maybe not your dentist but your hygienist. The dentists themselves are very busy going from patient to patient. You at least have some time with your hygienist. So in humans, your molar or your premolars, they call them 1 and 2. The 1 being the one toward the front of your mouth, 2 being the one toward the back. That's not correct. Evolutionarily, that is the 3rd and 4th, because we lost the first 2. And in zoology, talk about non-human animals, they're always called what number they are if all the teeth are there.
Right.
So
I'm going to go yell at my hygienist about that because it's definitely her fault.
Yep.
Or his.
Yes.
Or his.
Sorry, that was...
in my office, there are women, but yes, like...
I didn't... It came off more aggressive than I wanted it to.
That was appropriate for you. But no, and obviously don't be antagonistic to your hygienist about it. They're just doing their job.
I don't know. It sounds like Fia's about ready to slap me over this. So say whatever you want, hygienist.
No, it was neat. It was just a neat conversation that I had with my hygienist. She thought it was really neat. She thought it was really cool. Yeah. So in every other primate, we call them premolar 3 and premolar 4. But in humans, for some reason, it's 1 and 2. And with that, I've talked long enough. Send us home, Mike.
Number 1 and number 2 is what I think of both of you guys. So thank you very much for this podcast.
Wait, who's who?
I mean, Gavin, you and I started this, so I think you have to be number 1. And then Fia joined in second. So,
Sorry, pal. See, I thought you were just going to leave us guessing.
Nah, not after today. It's been a wild one, but thank you very much, Gavin. Thank you, Fia. And thank you to you, the listeners, for hanging along with us. This has been episode 133 of I Wish You Were Dead, a podcast about things that used to be alive. My name was Mike, and we'll see all of you guys in 2 weeks. Take care, everybody.
Bye.
This episode of I Wish You Were Dead was written by Gavin Davidson and hosted by Gavin Davidson, Mike Bryson, and Finella Campanino. It was sound edited and edited for YouTube by Gavin Davidson. Special thanks to former guests of the pod and to listeners like you.